Hi, Assalamualaikum warahmatullahi wabarakatuh. So in this video, we are going to revisit example 2.5 of finding the limiting value of this function, and also example 2.3 related to finding the limiting value of another function given here. Alright, and I'm going to show you guys that direct substitution is not applicable in these two examples here. So direct substitution, which you have seen, cannot be applied in these two examples here, and I'm going to show you why. Now the reason why is that if you substitute t equals to 0 into this function, you will have a problem of computing the value, because when t is equal to 0, if you substitute into this, you end up getting the result is going to be, okay, if you substitute t equals to 0 into this function, what you get is you will get 0 squared plus 9 minus 3 over 0, and this is equal to 3 minus 3, which is 0 over 0. And the problem here is at the bottom part here, because you cannot have 0 as a denominator, as the answer is going to be undefined. You cannot compute the value of that, so that is the problem. Similarly for this one, if you substitute x equals to 1 into this function, what you will have is, for the denominator, the value here is going to be equal to 1 minus 1, which is equal to 0. And there you go, you have a problem in computing the value of this function here. So what we're going to do is we are going to change the appearance of this function. We are going to manipulate, we are going to transform what we have here with something that looks slightly different, but in reality it actually still carries the same idea of the original function. I'm going to explain to you. For example, let's say I have this function here, fx is equal to 3x plus 5. Now it is also similar if I write down fx is equal to 3x plus 10 minus 5, because the end result is still going to be 3x plus 5. Now if I want to make it slightly complicated, I can also say that this is equal to 3x plus 10 minus 5 plus 40x squared minus 40x squared. So still these are equal, okay, because this one can be cancelled out, this one becomes 5, so we got 3x plus 5, which is given by this original function here. Similarly for this one, this is equal to 5, where basically you have the same outlook as given on this first function here. Alright, so that is what I mean when I say that we are going to change this look to something else, but the original idea is still there, or the original function is still there, just that it has a different look. Okay, all right, so that's what we're going to do. Yep. Okay, so let's start with this function here. How are we going to change the look of this function? So let's say we have this function, t squared plus 9 minus 3 over t squared. Now what we can do is I can introduce something which is, I can introduce this multiplied with t squared plus 9 plus 3 over t squared plus 9 square root of that plus 3. Now I hope you can see what I'm doing here. Okay, so this is the original function, and I introduce a different term here, but you can see that this term here is actually equals to 1. So 1 multiplies with the original function, you will get back the original function. So it doesn't change the original function. I'm just like trying to manipulate and modify how it looks like. Yep. So by doing that, we can continue with the process. What we have here is for the bottom part, it's going to look like this. Okay, you multiply this with this one, so it's going to look like this, t squared. And we have t squared plus 9, the square root of that, plus 3. Okay. Alright, now for the numerator part, what you can do is you have to multiply this term with this one and then with this one, okay? Similar to expanding the two items which we have done before, and then negative 3 will be multiplied to this part and negative 3 will be multiplied to that part. Okay, so what we're going to have is, if you do that, and you can see that since negative and positive sign, the term will be cancelled out. So we can simplify that to having t squared plus 9 minus 9. So this is what you're going to get when you multiply the two terms here. If you're not sure what's going on, imagine we have square root a minus 3 times with square root a plus 3. So if you have square root a times square root a, you will get rid of the square root sign here. So you will have a. Now square root a times positive 3, you will get positive 3 square root a. Now negative 3 times square root a, you will get negative 3 square root a. Negative 3 times 3, you will get negative 9. This can be cancelled because the signs are different and they are actually the same item here. And you will be left with a minus 9. So similar to what we have here, we get rid of the square root. So you will have t squared plus 9. And then negative 3 times 3, you will get negative 9. So that's it, really. Alright, so now how can this be further simplified? This can be further simplified if you write down. You can see that 9 minus 9 can be cancelled out. T squared and t squared at the bottom can be cancelled out. So we will have 1 over the square root of t squared plus 9 plus 3. So this is the look that we have changed from the original look that we have here. Alright, so now we are going to consider this new function and then we can apply direct substitution. Okay, right. Okay, so next what we're going to do is we're going to consider this function here. So therefore, limit t approaches 0 for this function, which is t squared plus 9 minus 3 over t squared, can be said equal to limit t approaches 0, okay, for this function 1 plus t squared plus 9 plus 3. And once we have managed to do that, we can just do direct substitution. We can substitute 0 into t. So you will have 1 over 0 squared plus 9 plus 3. And here we will have 1 over square root of 9 is 3. 3 plus 3 is 6. So 1 over 6. So that's the answer to this question given here. Okay, right, let's look at the second example here. I'm going to erase all ink on this slide. Okay, so let's look at the second example here. Now for this one, we're going to change the look of the given function here, and sometimes we don't need to introduce a different term. We can just simplify the function. Okay, as an example, so we can see that limit x approaches 1, x minus 1, x squared minus 1 can be written as limit x approaches 1. Here we have x minus 1 at the top part, and we know that x squared minus 1 can be factorized as x minus 1 and x plus 1. Okay, x squared minus 1 is equal to x minus 1 and x plus 1, and based on this you can simply cancel the terms out. So what you have is you have limit x approaches 1 over x plus 1. And based on this, you can see that if you substitute 1 into this function here, there will be no issue in computation and you will be able to get the answer. So now we are going to just consider direct substitution, and it is going to be equal to 1 over 1 plus 1, and this is equal to 1 over 2. Okay, right. Now, next, based on the explanation above, do you think you can come up with the answer to a question in example 2.4? So in example 2.4, you are given the simple graph, a straight line graph, where the function is looking like this. The function is a bit complicated. It doesn't at one glance look like a linear function, whereas the graph given in that example is a linear graph or a straight line. Okay, so how can that graph be a straight line graph when this function at one glance doesn't look as if it's a linear function? Yeah, so it goes back to the same idea which I have mentioned just now. For example, if you have this function, so we have limit x approaches 4, x squared minus 6x plus 8. This one is x minus 4. Now you can see that if you substitute 4 right away, you will have a problem, because then the denominator becomes 0. So 4 minus 4 is 0. So you have an issue with that. So what we're going to do is we are going to do some sort of modification or simplification or manipulation. Depends on the situations that you have. So now this expression here, it can be factored into, if I write down, it can be factored into x minus 4 and x minus 2. Now you can try expand these two factors here, and you will see that the result is going to be x times x is x squared, x times negative 2 is negative 2x, this is negative 4x, so negative 2x plus negative 4x, you will get negative 6x. Negative 4 times negative 2, you get 8, positive 8. So this expression here can be factored into two terms. And here we have x minus 4 at the bottom, which you can see clearly this can be cancelled out. So we have a function that is a linear function, x minus 2. Okay, so now from this function, it can be reduced to this one here. So we have limit x approaches 4, x minus 2, and you can see that if you substitute the value of 4 into this function, it has no issue whatsoever. So you'll be able to get the result, and the result is going to be equal to 4 minus 2, which is equal to 2. And if you go back to this example 2.4, you will see that the graph for this function looks like this. So this is x, this I'm going to call this fx, and we have this function. So here we have fx is equal to x minus 2, where we know the intercept is at negative 2, and when the value of y is 0, x is going to be equal to 2. So we have a straight line graph that passes through this point here, and remember that when you have 4, okay, when x approaches 4, so this is the value of interest. Okay, I'm just going to change the color here. So 4 is the value of interest, where it can come from this direction or in that direction. And you can see that for the specific point here, if you substitute 4 into the original function, you substitute 4 into the original function, this function cannot be computed. Because why? Because the denominator is 0. So therefore, at point 4 here, there is this open circle, which indicates that there is no value for x equals to 4. However, based on the definition of limit, it doesn't matter, because the limit considers values that are approaching 4. So if you approach 4 from the right direction, the value of y is going in this way. It's going to be somewhere close to this value. So this value is actually 2, yeah? 2. So it doesn't matter even if it is open circle, it doesn't matter. So you will get the value here from the right direction is equals to 2. Now if you approach 4 from this left direction, well, the value of y is going upwards, and it will get closer and closer to the value of 2 given here. So therefore, the limit of this function is going to be equals to 2 when x approaches 4. Alright, I hope my explanation is clear to you guys, and I will see you in the next video. Thank you for watching.